Okay, geometry fans, our topic for today, we are in section 1-5, angle relationships. And our objectives, two things. Number one, we want to identify angle relationships. And number two, use angle relationships to set up an equation and then solve for a variable or an angle measure. So before we start, let me tell you your joke of the day. Why was the strawberry crying? Well, his mother was in a jam. Okay, so the first thing we're going to do is we're going to kind of discover a relationship that we've already talked about, but if we take here's angle 1 and here's angle 2, and we're going to measure both of these angles. Now you'll notice that together they form a straight line. So we learned last time that a straight line is 180 degrees. Let's verify this. So I'm going to take a protractor here. If you haven't used one before, we're actually going to use these in class as well. So where I line it up at 0 at the bottom, and then I look at where the other side of the angle, the ray, hits the edge of this, and it's about 50 plus a couple. So I'm going to approximate and say that is 52 degrees. Now that's angle 2. Okay, so there's angle 2. I'm going to put an arc there for that. Now for angle 1, since angle 1 is pointing the other direction, what I'm going to do is turn my protractor so that 0 is now facing left, that it lines up. And again, I will turn this so that it lines up with the other ray. And what we get is almost 130. It's about 128 degrees. So again, I'm approximating here. I'm going to use 2 arcs for that because those are different angles. Okay, so they're not the same. So I'll use different arcs. Now, angle 1 and angle 2, notice how they're kind of next to each other. We say that these are adjacent. Those angles are adjacent. That means next to. Now, the official definition, if I trace these both out, adjacent angles, they share a common ray, a common side, and vertex, but none of the interior points are the same. So any point that I put inside angle 1 is going to be different from angle 2. They're not going to be the same. Okay, so adjacent means they share a common side and vertex, but no interior points. If a point is inside one angle, it is not inside the other. Okay, and the basic idea here, if you look at these at the bottom, they form what's called a linear pair. It's 2 adjacent angles, so 2 angles next to each other that form a line. And remember that a line always adds up to 180 degrees. 128 plus 52 is equal to 180, so this actually works. So they form what's called a linear pair. They form a line. Another word that we're going to say is that they are supplementary. Supplementary angles are 2 angles whose sum is 180 degrees. Sum means to add. So in this case, we have angle 1 and angle 2. The measure of angle 1 plus the measure of angle 2 is equal to 180. So if you have 2 angles that are supplementary, you know that they add up to 180. In this case, they also form a linear pair because they form that straight line. Okay, so those are 2 very important words and 2 things that we are going to be looking for today. Now, number 2, we're going to measure all 4 angles. We're not going to use the protractor. I'm going to tell you, though, that angle 1, the measure of angle 1 is 132 degrees. Now, here's what we can do. If you look at angle 1 and angle 2, if I trace that out, notice how they share this side and vertex, and then notice how this goes in opposite directions, and it forms a straight line. So angle 1 and angle 2 form a linear pair. Well, 180 minus 132 is going to be 48 degrees. So angle 2 measures 48. These are supplementary angles. They add up to 180. Okay, now let's compare angle 2 and angle 3. If I trace those in red this time, there's angle 2, here's angle 3. Notice that they form a straight line when I put them together. So that means that these add up to 180. Well, if I take 180 minus 48, what's left is 132 degrees. And so using the same logic, angle 3 and angle 4 form a linear pair, so this will be 48 degrees. Now here's the thing that we want to recognize here. Angle 1 and angle 3, they are congruent to each other. 1 and 3 are congruent. Also, 2 and 4. Angle 2 and angle 4 are congruent. Those have the same measure. Okay, so we're going to jot down a few things on the side. Supplementary angles. Supplementary would be angle 1 and angle 2. I'm going to use a symbol for the word and. It looks kind of like an A. We'll get into this more in logic, but just to save a little time, angle 1 and angle 2. Then we have angle 2 and angle 3. Angle 3 and angle 4. Angle 1 and angle 4. So we have a lot of pairs of supplementary angles. Now, the other word that we're going to use here, congruent. Remember, congruent means same shape, same size. Angle 1 and angle 3 are congruent, but also angle 2 and angle 4 are congruent. Now, one thing to mention is that they're not all congruent. Not all 4 angles are the same, just this pair and this pair. Now, what we call that relationship, they're called vertical angles. Vertical angles. So the definition is 2 non-adjacent angles formed by intersecting lines. Non-adjacent means they're not next to each other. If you look at angle 1 and angle 3, they do have the same vertex right here, but they don't share the same side. These 2 red sides are totally different from these 2 blue sides. Okay, so that's non-adjacent. Now you might look at this and say, okay, they kind of look like they're opposite of each other. Yes, that's true, but we're not going to say the word opposite. We call these vertical angles. Vertical angles are always, always congruent. That is always going to be true. So anytime 2 lines intersect, so if I draw 2 lines here and I'll number them 1, 2, 3, 4, you always know for a fact that we can say these 2 angles here, I'm just going to shade them in. Those 2 have to be the same, and then these 2 have to be the same. Each pair of vertical angles is going to be congruent. Okay, so we can always say angle 1 is congruent to angle 3, angle 2 is congruent to angle 4. And when you have things that are congruent, you're going to have things that are equal as well. So vertical angles is really important. Supplementary means they add up to 180. Okay, so if we come down to the bottom here, identify each pair of vertical angles. Now you actually have 3 lines crossing. Well, let's go ahead and trace 2 of them. Let's take these 2. Now the 2 angles that are vertical that get created by the 2 blue lines are angle 3 and angle 6. So that pair is going to be congruent. So angle 3 is congruent to angle 6. Now let's pick a different pair of lines. I'll take this one again, put that in red, and this one. It's important to trace this out, especially when you have a lot of lines, because it makes it easier to see the relationship. So which 2 vertical angles get created by the red lines? Well, angle 1, angle 4. Notice I put 2 arcs there because I don't know that it's the same as angle 3 and angle 6. But angle 1 is congruent to angle 4, That has to be true. And then the last pair, I'll put in green. Now those two angles, that's angle 2. I'll put 3 arcs. Angle 5, 3 arcs. Angle 2 is congruent to angle 5. Okay, so we actually have 3 pairs of vertical angles. Each pair is congruent to the other. Okay, so one way that I remember this, anytime 2 lines cross, you will always have 2 pairs of angles that are equal to each other. The way that I've learned this, I actually got this from a student. They labeled A, B, B, A. So what they did was they said, okay, I'm going to put an A here for this angle, and I'm going to put a B for the angle next to it. Now we know these are different, okay? So A and B, those are different, but vertical angles have to be congruent. So if that's a B, this is a B, so I'll put a B there, and if that's an A, this is an A. A, B, B, A. If you compare 2 A's with each other, the A's are equal to each other. If you compare 2 B's with each other, because they're vertical, those are equal. But if you compare an A with a B, now those are next to each other and they form a straight line, they must be supplementary. So they add up to 180. So an A and a B add up to 180, but if they're the same letter, they're congruent. If you think of a different way to help you remember, then you can use that. Okay? Supplementary, but if they're the same letter, they're vertical, so they're congruent. So we're going to do a couple examples now. If we look at the back, so we'll take number 4 here. Find the value of x, the measure of angle CBE, and the measure of angle DBE. Before we start trying to figure out all those angle measures, let's look at what they tell us. So look at where you have variables or degree measures. And it looks like we have angle ABC at the top. This is 4x plus 7 degrees. And next to it, we have 6x minus 17 right there. That's 6x minus 17 degrees. So that's for angle CBE. Now, we have to ask ourselves, are they equal or do they add up to 180? Well, they're not the same angle, they're not vertical, but together they make this straight line. They're adjacent, they form a linear pair, so that means they are supplementary. So these add up to 180. So we're going to make an equation, 4x plus 7 plus 6x minus 17 is 180. If they add up to 180, if they're supplementary, then I'm adding these to get this. Okay, now to solve it, let's add like terms, same side, 4x plus 6x. Let's also do positive 7 minus 17. That's minus 10 when I combine that, equals 180. Now I'm going to move to the other side, plus 10, plus 10. So we get 10x is equal to 190, and the last move is divide by 10, and we get x equals 19. Okay, so we're pretty confident that we're right, but let's plug it back in. So let's take 19, let's go back to the picture, let's substitute for the x's. So 4 times x, 4 times 19 plus 7. 76 plus 7 is 83 degrees. And then 6 times 19 minus 17. That's 114 minus 17. That's 97 degrees. Now that actually looks great because these add up to 180, which they should. So that's your check. So what did they ask? They say find the value of x. We got it. Measure of angle CBE. CBE, that's the red angle. That was 97 degrees. And the measure of angle DBE. Now, DBE is this angle. Uh-oh, we don't know that. But actually we do because we have vertical angles. So that's 83. Measure of angle DBE is 83 degrees. And that is the end of part 1 of the notes.